All right, guys, welcome back to another KevCAM night class tonight. Got something special for you guys tonight. So before we get rolling here, I do see a couple new names in here. So just as an introduction, these night classes are solely dedicated for you guys for your training. We do use GoToWebinar for these night classes, and it does put everybody in mute. But if you do have a question, come up, please. There is a questions panel. Go ahead and ask that question in there, and we'll answer them right on the spot for you guys. And tonight we are going to be covering Swiss. So I got Tim Micah helping out with any questions or concerns that come along the way for you guys. Tim, are you with us?
Yep. Good evening, everybody. And I'll send a quick little question in that questions panel there just to for everybody to see where that's at. So I'll try to send that to all, and then everybody can see that's the panel to put the questions in. And I'll keep an eye on that for Kevin.
Perfect. Thank you. And then we do have a special guest all the way from Europe, Daniel, with us, which is our resident Swiss guru. Daniel, are you with us?
I'm here. Hello, everybody.
And then Greg Payton is here to help with us along the way too. So we're actually doing a special on-site training for a customer over in South Dakota. And while we have Daniel here, let's do a night class on Swiss for you guys and kind of give you guys a brief overview of how the Swiss works inside of SolidCAM. Not a lot different from what you guys are used to seeing with Milturn, but there are some added stuff in there. So with that being said, well, of course, all of the night classes are being recorded for you guys, and you guys can check it out at SolidCAM University. If you guys want to re-watch this, or if you guys are looking for part files, just shoot me an email. And if you guys do have questions later on, I just put my email into the GoToMeeting chat for you guys. So you guys should have that there. But just want to say thanks for joining. And Daniel, I will let me switch it over to you here, and we can kind of get the ball rolling. All right, switching over to you, Daniel.
All right, let me share my screen. So hopefully everybody can see it.
Yep.
All right, first, before I started, I would just like to express my feelings and how it's basically my pleasure to be in the KevCAM class, yeah? So let's get started. So the first, I prepare a small presentation to all of you guys who don't know what the Swiss type basically is, or you maybe might heard about it, but you have basic knowledge about it. So basically, we will just start from the fact that since SolidCAM 2018 version, we can successfully support Swiss type machines. And one of the things that I'm gonna show you here is just a few pictures of what we are capable to do of, and this slide is basically of how in details we are going in with those stuff here. All right, first of all, on the market there are commonly known as many have different terms, yeah, but usually it's like we call it here Swiss type machines, but basically it is also common to hear like a Swiss style, precision automatic lathes, Swiss screw, Swiss automatic, Swiss turning, long turning also. I heard that quite not long ago. So, but basically I will use a Swiss type term in this case, okay? So we are talking about the same machines here. Basically, I'll not talk too much about the history, okay? But they're not necessarily made in Switzerland, okay? The first concept actually was used there for the watchmaking industry, but the Swiss doesn't mean that they're made basically in Switzerland, okay? They're mostly today used in a lot of medical, first of all, electronics, automobile industry, as you know. But more and more it's in medical. I can say that for sure. And in the past few years, it has the greatest impact there. basically what the Swiss type machines are. Okay, why they are so popular. Their machining provides a cost-effective way to produce very small, complex, and precision parts in the large quantities. Okay, I'll go back to this sentence also in a couple of more slides here. This is very important to say. But regarding to the materials, they can cut basically everything. Yes, I think there's no limitations in this area. Yeah, but what is very important to mention here are the dimensions about the parts. They are up to 36. I will correct this. Maybe it's up to 38 mm. And what is very interesting fact is the length diameter ratio bigger than 5 is possible. Okay, so this is very important. I'll go back to this also in a couple of more slides. I put this picture over here. The tree in the background, you can see pretty much common mill turn machines. You probably could recognize it. And in front of those machines are 3 Swiss type. And back to the sentence that I mentioned in previous slide, saying that they are cost-effective way. It's they really are. Besides of the cycle time, they're really economic in producing those parts. So even if you can have equally cycle time on the machines that you can see in the background, I would say regular or conventional mill turn machines, you cannot beat those in the front because they are just simply more effective and let's say power consumption for making those parts are much less in comparing to the one that you see in the background. Okay. And I'll now mention what is the main concept, what they are so different. What you can see here, it's just a pretty much standard thing what you all already guys. It's clamping very thin part in diameter and having it pretty long out of the jaws can make the deflection and vibration. Of course, we can also use the tailstocks in these cases, but again, it's with a Swiss type, which I will present you in the next picture, is we do have over here on the right side of this picture over here, we have jacking collet basically that moves the bar along the z-axis through the guide bush. Now, the purpose of the guide bush is just to offer additional support on the stock material, which actually allows us to make the parts where the diameter length ratio is bigger than 5. Okay, and in that case, the deflection and vibrations are minimized. Over here, I just put some of the brands that we are very familiar with and have a nice cooperation. On the top are the I would say the Tornos, DMG, and Index, and on the mid-size the Star and Citizen, and also Tsugami, very popular also on the market. This is slide basically with all those which we already made some posts here. And the real question is also coming why we choose actually to go in the Swiss type direction. Okay, besides we saw first of all that it's high market potential. Okay, also besides of really giving the support over the Swiss type, it also improves a lot of things in our regular mill turn solution. Okay, so like a complete solution, it's pushed to the higher level basically. And over here we also have quite a lot of customers. I'm not sure how it is here in US, but in Europe there was a lot. And of course, coming over here, I can see that here there's a lot of customers who are having the Swiss type machines. So our customers are asking constantly, can we support those? So this is one of the main reasons why we are going in this direction. And yeah, only the most advanced CAM on the market can do it. Okay.
Yeah, and if I can just jump in here, Daniel,
Yep.
our only default before, we could do 5-axis, we could do mill turn, we could do complex mill turn, but our only factor before is we couldn't do Swiss, and now the gates are open for everybody that has a Swiss machine. So it's kind of nice to know that SolidCAM is definitely the one-stop shop for you guys now.
Yeah, exactly. So with all Swiss type customers basically have a lot of difficulties. For all of you who don't know the Swiss types, this will be pretty interesting fact. But also for all of you guys who have the Swiss type machines, probably know that all the G-codes that you are programming on the machines are done manually. Yeah, so most of the cases, what I've seen it's just all the operators holds the knowledge about it. There is no visual verification, so the running every single part, it's a nightmare. So you need to be very careful, especially when we are talking about very, very difficult and complex machines. Yes. Over here on the left side, I just put also operator holds the knowledge. Yes. So it is very frustrating when the operator needs to know all the machines that is on the shop floor. Yes, it's he usually forgot something. There's a lot of M codes. There's a lot of G codes. Programming each one of those machines, it's really crazy. Yes. Besides of that, today I can see on the market the machines start to be very complex with at least one B-axis. There's recently I saw like 3 B-axis on one Swiss. So with those machines, you simply cannot program it manually. The only solution is to have a CAM solution. Yeah. And besides of that, also parts are getting more and more complex. So doing it manually, it's just in most of the cases mission impossible, or even more, or I would say very, very complex to maintain. Okay. And now just a few slides about when do you need SolidCAM to run your Swiss. First of all, you will definitely choose regarding something about the part geometry. On the left side, I just put some of the parts. And if you are making those kind of parts, then you most likely don't need the CAM at all. Okay, but if you do have parts like I just show you on the right side of the picture, pretty much complex geometry, and then I've seen some of the customers who are programming those screws over here manually. This is, I would say, in some of the cases possible, but those over here, it's really, really complex, especially if you're changing the parts constantly. Then it can be time-consuming, yes, for programming those parts over here. And also, I put here this very nice part. It requires 4-axis simultaneously machining. In this case, I don't think so. It's possible to program it manually. And besides of that, I also put something like machine related. So if you have on your shop floor many different brands, yes, so most likely then you have lots of different M codes and G codes that the operator needs to know. So in this case, putting all the knowledge inside a CAM solution, it's the right direction that you need to do. Besides of the different brands, also if you have different machine models or machine concept, yes, the different axis configuration, and so in this particular case, it will be also a good way to go into a CAM direction. 5 and more control axis, and also from another side, also the tool layout. It's very important. If it's very complex as on the machine that is on the picture, then yeah, then definitely I would recommend that. Then we do have like a 5-axis positioning and simultaneously. Just on the right side, I just put small video. I'm not sure how smooth it will look on the GoToMeeting, but basically it's just all right. So basically it's a 5-axis simultaneously and positioning that is pretty, I would say, on most of the cases, it's impossible to program manually. In that case, you simply need CAM. All right. basically, this was what I wanted to show you a little bit about what the Swiss type machines are, okay? What you can do with this. And I'll just jump into the software a little bit and say a few about this. Over here, just create one that is pretty common also, I can say, and also on the Swiss market to see something like this. Basically, for all of you who program already in SolidCAM for turning and milling, there is basically no differences in programming. So we keep the consistency in this case, okay? What is actually different is that we are now able to configure unlimited numbers of the axes and inside and the SolidCAM, the machine simulation, the tool layout, and everything. So we basically don't have the limits about it. Okay. So what I'm going to do here, and the first thing, I'll just jump into the setup itself, so I can show you the machine that that is a Swiss type Star SR38, which has the main spindle on the left side. Let me just try to zoom in this, maybe a little bit over here. So on the left side, we have main spindle with a guide bush. On the right side, it's our back spindle. It has a lot of tools, turning tools on the left side, also the 52 and 53 on the right side for the balance raft. We do have the radial mills over here, also the one on the top. And we do have also the B-axis. I can also move here the B-axis the thing that we also have like a central drilling or turning tools over here. And also we have the back tool post over here for the back spindle machining. So this is regarding to the setup, and I'll just jump the tool table itself. All right. So on the left side, we just have all the tools that are connected to particular station on the turret. Okay. We over here we have the list of the turrets. Okay. Pretty. I would say pretty complex. All the tools that I show you. The turrets that I showed you a few moments ago. I'll go also to the mounting, and it's very critical and very important to have very correct and easy way to define all your tools in SolidCAM. Okay, sorry, I mean in general. So what SolidCAM provides you is machine preview, where for each particular turret and the station itself provides you visual overview of how your tool will be defined. Okay, how is defined. Everything what you see over here, it will directly reflect and have influence in machine simulation. Okay, so over here we have all the tools on the back for the back spindle, all the turning tools, milling tools, and the tools on the B-axis itself. And it's pretty intuitive, as you already know. In 2018, I would just I don't know here what to show, but let's go to the turning over here, the tool over here first. I'll just go to yep.
Is it safe to say that, you know, with your turrets and all your different tooling that where you grab that drop down with all the different tool positions there, that would already be set up for the post or per the machine by the post processor, correct?
Yeah, basically, exactly. And I will just mention one more thing here. Once you create all your tools for the particular part, you can definitely save it, since it is pretty common that the tools will not be changed that often on a Swiss machine. So you can always use the same library, importing it in every single part. Yes. So over here, it's just I just want to show how intuitive it is, changing any of the values over like a tooltip position, a tool length over here. Maybe I can just jump to the tool number, I don't know, 8 over here that it is. So changing this value over here, it dynamically reflects to what will be shown in the tool mounting itself. Okay. Now I'll not save this. So basically what I have here, it's a lot of operations done on the main spindle. Okay, so nothing too special about it. The only thing what I'm gonna mention here is that doing the operation on the Swiss, yes, because of the purpose of the guide bush, it is kind of limited to make some turns, like you get used to it, guys, like doing it in complete length. If you have the guide bush version, in this case, your turning operation must be basically done in partial, okay, so like a partial machining, like I did it in this example over here. So I did a couple of the turnings, you know, so doing the everything in going from right to left, finishing all the parts as in that strategy, basically. Once you define all the operations for the main spindle, the main difference in comparing to the mill turn is to the mill turn for conventional is that over here we do have like a machining data. It's the particular MCO that I'll just go to edit and just show you. It allows us to define where it's my machining start position. It's very important parameter for the Swiss screws. Okay, I'll just open the machine preview over here. It shows us basically where my chucker is positioned for the machining the part. Okay, so I'll just click over here and you can see the most updated position of the chucker itself. Besides of that, we also have some of the machine parameters that is directly connected to the specific post processor, which is also very, very, very important. All right. Besides of everything, I will just also show you a little bit more about part transfer over here. I'll just go to the very first MCO operation, which is basically taking the cutoff tool into cutoff position, also prepositioning the Z1 axis for the cutoff. That I'll just go to the parameters over here, and what we do have here is just a few parameters that we need to set up. It's like a cutoff preposition. It's the how much we want to extend the part out of the guide bush, and I would just like to mention a few things here that we also have here the the machine preview, where I can just click over here. I will try to zoom in a little bit. So clicking on this, we can get the most updated position over here. We can also select the cutoff tool. As you can see, everything it's very dynamic. I can go to the preposition, and we can, let me just go to the bottom. I think it will be much better. Yep, we can see here the cutoff and position. Okay. Also, we have like a direction, rotation, and spin for the cutoff operation. Besides of that, this is the very first MC operation, and after that, there is like a back spindle where it will provide a pickup. And let me go to the parameters itself. And what we have here, it's a couple of also parameters here, which I'll again can show you. And this is kind of very important. Before you actually go to machine simulation and generate the G-code, it is very nice to actually see what is going on in the machine preview. I really like this. This is my favorite feature in 2018 for sure. It comes also in 2017, but we improve it a lot also with coming up with the Swiss type. So over here we do have on our right side, I'll just show you here the back spindle, and the very first parameter here it's like safety preposition, where you need to put a value of how much you want to be in front of the part before you go to the clamp position. And as you can see, I choose to put 2 mm. Then we have the clamp position. Here's the clamp position. We also have the clamp feed. I just save and exit. And there's nothing then different. Basically, we do have also the cutoff in that case. We have the those are for the taking the part basically to the home reference. And then we have here the couple of the operations also done for the back spindle. Okay. So it's what I can say that it's, as you all know, we are pretty intuitive in programming. So I'm not doing anything special. We are not changing the way how the parts are programmed. Okay, so everything is pretty much done with the standard operation, as you can see it over here. The only difference that I can mention that for every Swiss type, it's very important, is to have the part release MCO at the end. The part release, it's kind of, I would say, a flag that can say to the software where actually my machining is done. And this is very important for the channel synchronization that I want to show you in the next few seconds.
Yeah. And
with a part release,
if I can hop in real quick.
Yeah.
With what, just for everybody's knowledge right here, what Daniel's showing you guys with these MCOs is when you guys purchase the Swiss module from us in the post processor, these MCOs would be created for you guys, and you guys can come in there and modify them per the part itself. So a lot of this stuff that Daniel's showing you will be pre-set up for you guys for doing part transfers. Any MCO in there will be kind of pre-set up for you guys. So I just wanted to throw that out there for you guys. So as Daniel's going through it, you know, I see Ronnie's eyes getting, oh man, this looks complex. But like I said, this is, you know, it's no different than doing a standard mill turn, except we just have a couple MCOs in there. And Daniel's going to go over the channel sync. But what the main factor that we've changed to support Swiss is more on our end versus on the machine end. And what I mean by that is the post processor side, to make sure the post is outputting the correct parameters and can work with all the different axes. So, sorry, Daniel.
Yeah, it's okay. I think the question is on the right spot. I will not say that it's complex. It's just like a logic that you need to do it anyway, either on Swiss type while if you want to program it, for example, manually. In that case, you also need to do the same stuff what we are doing right here. Over just it's pretty intuitive. You can see everything. You can simulate it and so on. So basically, for sure, you need to always take the cutoff tool. You need to pre-position your part. You need to take it with a back spindle. You need to do a cutoff. This is the procedure that it's always the same for every single Swiss type. So what we are giving you as an option is to create a process template, okay, where you can just select multiple operations like I did over here. And what you can do here, you can create a template, and you can name it up to for your machine. And every time when you're programming with this machine, you can just insert this template and just change for a few parameters here. This is what I'm usually doing it, you know. So in order to speed up the things, okay. With that being said, I'll just jump to the channel synchronization, which is the crucial for the working of the Swiss type machines, since all Swiss type machines are at least 2 channels, okay. To jump into channel synchronization, what you have to do is just do a right click on the setup and go to the channel synchronization. Another way to do it is you can go to the, I'll just here larger buttons, and you can go to the SolidCAM operations, and you can find the channel synchronization also over here. So I'll just zoom in here. This is the channel synchronization. I'll just try to delete all labels, okay. Now, what we have over here is basically the interface for making the operations work together, if I can say in that way. So we can synchronize the operations from each channel. On our left side, we can see the path 1, which are basically on Swiss type machines. Everything what is done at the main spindle, it's on our left side, and everything what is done on our back spindle, it's on the right side. And if I leave everything like it is here, I will just try to show you a little bit what is inside the interface, and then we'll go forward in order to show you how the simulation works and the G-code. So on the top left, we do have like a synchronized select operation start to start, and I can pretty much represent what is going to happen. Basically, it will take two operations, and the wait mark will be inserted before that. Then we have like one after each other, and then it will end together. So it's like operations end to end. We also do have like synchronize all operations as it is in the country order. I'll do that in a couple more moments. The reason why I don't want to do it right now is just to show you that that this icon over here is a clash view. The clash view means, okay, something is wrong with a sync labels, and we will not allow you to generate the G-code or either to simulate it. And as you can see on the left bottom, we do have the simulate button. We also have the G-code button, but even if you try to click on this, the software will not allow you because the logic is put inside. Okay, so what is wrong? You can basically click on the operation clash view, and all operations will, in this case, it will all be marked because I just have here the set of machining data. It's like done before I have the operation, the back spindle, so this is not possible. Okay, so basically the logic is inside. So a couple more things here. We do have here adding a new workpiece. This icon represents the position in channel synchronization in the moment when you want to split your part machining. So basically we'll get a machining of the same part while doing it in parallel, either on the main spindle and the back spindle at the same time. I'll show you that how it looks actually in machine simulation. I'll mention that all Swiss type machines run under this function basically.
And as just a kind of a general overview of what channel synchronization is doing is basically we're able to take multiple operations, and some that are on the main spindle, some that are on the sub spindle, and the software is looking to see when we can actually do both of those together without
exactly
crashing or any interruption or anything like that. So that's the whole purpose of the channel sync.
Besides of that, it's also allow you to minimize the cycle time. That's the goal behind the scenes. Yes, so the goal is minimize the cutting time on for the specific part. Just a few more icons over here. I'll just explain. There is like we can go to the operation duration. We can change here. We can see also the operation durations for each of the operation over here. We also can go to the time frame view. We can also see the operation clash view and turn it on and off. We can change the colors respecting to our turret. So you can see for each turret different colors of the operation. We can go to the color operation by table, which means basically different color for the main spindle, different color for the back spindle. All MCOs operations which have kind of part transfer are defined by the yellow color. And we do have like a color by the workpiece. And in this case, as you can see, that all the operations are kind of yellow, which means that in this case we are only machining on single part. But I will show you that in this case, when we use this adding a new workpiece, we'll kind of have two parts over here in this channel synchronization. Nice thing over here is like we can always import the channel synchronization status. So for instance, if I start to play with the channel synchronization and I'm not sure that this is the best way to machine this part, I can just export it. I can name anything, and later on I can always back to this channel synchronization. Okay. Also, we do have kind of reload button, also undo button, some of the settings, and that's pretty much of the channel synchronization. Okay. So let me just show you how actually everything works. If you just select this button over here, he will basically do everything according to the CAM tree order. Okay, so all the operations will be grouped in that way. So as you see, we do all have everything with the main spindle. Then we have a couple of operations, MC operations for the part transfer, as you can see over here. And then we do have a part machine, it's machined on the back spindle. Everything is completely fine. As you can see, the simulation is allowed, G-code is allowed. You can also export it. We can also export it. We'll say this is kind of default. Okay. But this is usually where the customer for the freestyle machines will not be impressed. Okay, like machining everything on the main spindle, then making a part transfer, then doing something on the back spindle. It's not what all Swiss type customers would like to see. The Swiss type customers like actually to minimize their cutting time. Okay, the cycle time. In order to do that, the both spindles should work simultaneously. Okay, all the time, whenever it's that possible and physically possible in the machine. To do something like that, it is very logical to split the program on the very first operation that is going on the back spindle, for instance, in this case. So what will basically happen, I will just click on this operation over here, and now this add a new workpiece will be allowed. Adding a new workpiece, it's not allowed if you don't have the part release. In that case, the software don't know is the part program with this part done. Okay, so we need to know where the cycle ends for this part. All right, I'll just click over this operation over here, and then I'll click on this. So before I do that, what will happen inside behind the scenes is you can imagine like this is kind of big paper, and if you take the scissor and cut it over here, all operations that were on the right side on the bottom will go on the top, and all operations that were on the top will go to the bottom. So that's basically what will happen. So let me just show you how that looks. So I'll just click. So as you can see, this is what it happens. All the labels remain on the same place. As you can see, we can also start with simulation, but this is not what I'm going to show you over here. I will just like to, in this case, this is the weight mark label. In this case, I don't need it, so I'll just remove it. And I'll try to simulate this operation with turning operations on the main spindle. And I'll just using this with a control button. So I'll click on the first operation, using control, going to the next operation. They are both selected. And over here, I have synchronized select operations start to start. By doing that, I have two operations working together, main and back spindle. Now, maybe it's a good opportunity to show the color operation by the workpiece. As you can see, part on the main spindle, it's yellow. On the back spindle, I'm not sure what this color is, but it's completely different of what is on the main spindle, okay? And also, we can also simulate and generate a G-code. So let's jump to the simulation itself. And as you can see, going to the simulation, the channel synchronization will be kind of minimized. And if you do have two screens, it will allow you to move this to the second screen and just analyze all the operations and the labels that are defined over here. In this case, I'll just close it. I'll just go to the machine simulation. And besides of what I'm going to show you in simulation itself, of how the part it's a machine, I'd just like to also show you a new feature available in machine simulation. It's very nice for the machines that don't have a right angle to see both of the spindles, like this is the case. Let me just, there's a lot of tools here. Okay, as you can see, everything is the same as in the tool preview and machine preview. Okay, I'll go over here to move list, so we can see all the operations. There, you can also note that we have like two equal signs over here, which means that those two operations are done in parallel. Okay. So what I'm going to show you here, it's also we do have over here a new function. You can go into view, and it's called the viewports. Viewports, it's basically allow you to split the machine simulation into 2, 3, or 4 screens. Basically, not screens, but like a sections. So each of those then sections can have different state of machine simulation. So let me just show you what I mean about that. So let me go to the 2 rows.
And while you're doing that, Dana, I'm just going to throw in there that, you know, it did take a little bit a few seconds to pull up the machine sim, but this, with the Swiss module, it is not requiring a huge monster computer. Daniel
No.
and myself and Greg Abbas and Greg Payton, we're all running just Dell laptops. I think, well, Daniel, are you running an HP?
Yep, exactly.
So, I mean, we're not running any huge powerhouse computers here. So this does not require any, physical computer changes that you guys need to make. It's just continuing on of what you guys did before, using the same computers that you've had before. So I guess what I'm getting at or rambling on about is there's no need for special computers to compute all this data or anything like that.
Yep. So what I did basically, I just split the screen like a split simulation, and I just focused on the back spindle over here, all tools over here, and also we can focus over here for the main spindle. I'll just try to slow down the speed and just I'll run it. So the first operation is over here, just to put the headstock in the right position. Okay, and then we can see actually the machining over here. It's nice and smooth. Maybe I can speed it up a little bit actually.
So that's,
we'll not go.
So, I'm sorry. That's just so it just blows my mind that we're able to watch the main spindle right now and the sub spindle all on the same screen. We can see exactly what's going on right now.
Oh yeah, and besides of that, we can also go to the simulation, and over here I just focused on the workpiece and the stock, but I can just select the machine itself, so my screen will not gonna move. So basically, I can also, for instance, I don't like here to see this. This is the place where the part will be checked. So I can just do a right click, a double fast right click, and go to hide. And as you can see, the geometry it's hidden over here. While I will take a look on the first screen, you can see that it's still here. So it's kind of two states of simulation you can see at the same time. It's not slowing the system down at all. It's completely fine. You can see that over here. We just release the part. We'll continue everything on the main spindle. In this case, I can just stop it over here, go to the view, change to the to maximize over here. I'll just run it the part completely, so we can see also the part transfer. And for the end, guys, I would just like to show you the G-code a little bit, how easy it is to generate it. Let's just wait until the operation goes to the end. It's kind of nice to see also the part transfer. So as you can see here, there's nothing so special regarding to the programming itself. But yeah, besides of everything, I think the most interesting fact about Swiss type module is that we are if I can truly say, the only CAM system in the market that supports the Swiss type machines, and it's also integrated into SolidWorks and also the inventor itself. Okay, and this is complete machine part done, main spindle, back spindle, machine together. Two more things. I'll just say also the G-code. It's pretty much straightforward. You have a G-code button almost everywhere. You can click it in the channel synchronization over here. You can click it over here. You can go to the operation. Like everything, nothing. We didn't change anything at all. So I'll just go G-code generate. Click OK. And basically depends on from machine to machine, from controller to controller, the post will output either 1 or 2 codes, or maybe 3, or maybe the 2 channels will be in one code. Okay, in one file. Sorry, I'll just go over here, change the format a little bit, so you can just guys see what the output actually looks like. Okay. Okay, and the last thing, which is also very important to mention, is the associativity with a CAD. Okay. Over here I have pretty complex part, and the most problems that regular Swiss type customers faced off is if the drawing change suddenly, they need to change the program manually, and then the problems appear on many stages. You know, they need to verify again, they need to change if there is a compensation, they need to check that out also. So many problems then can appear. Okay. So what is very nice to show over here is I'll just jump to the design itself. I'll just change some of the geometries over here just to show you how the associativity works with the SolidCAM in this case. So just I'm not sure what to change here, but let me just go for the basics here. And it's pretty complex here drawing, so I'll just change this to something. Maybe yeah, why not? I'll just not change all of the stuff. Let me just put here to the 8 for instance. I think it will be fine. I think I will not. Let me see. Yeah, so as you can see, I got completely new geometry over here, and over here I extend this it over here. And once I'm ready, and once I have most updated model, I'll just save it. I'll go back to the CAM, and the very first thing I just turn off this feature. You can get it inside the settings, but for demonstration purposes, I turn it off because I want to show you how actually SolidCAM works in the background. So the very first thing is to check the synchronization. Okay, so we are verifying, checking if anything is changed inside the stock and the target. As you can see, you'll get this traffic light over here, and also for the all operations where this change actually it affects. Okay, so as you can see, there is quite a lot. And what I'm going to do here right now, I'll just go to the synchronization. So what is now happening is we are checking the model, we are checking the stock, we are creating new envelopes, we are creating new envelopes also for the stock, because sometimes it depends on all the parameters what you put inside. The SolidCAM will now try to synchronize everything with a design model, and it will mark all the operations that has to be recalculated. As you can see on the left side over here, you can see the all marked operations that has to be recalculated. So in that case, what you need to do, I'll just go to the right click, calculate, and he will notice, okay, but 19 operations are already calculated. Do you want to calculate it again? I'll just say no. And now I have completely new toolpaths and new G-code basically that I can just go over here, do a right click on the operation, G-code, generate, and go to the machine itself, and everything is ready. And this is basically what I wanted to show you for this KevCAM idle class, and I hope you enjoyed all, and I hope you have some kind of questions. Can I basically finish it? So if there are any questions, I'm ready for the answers.
No, we've been kind of keeping up with the questions as they've been going on here, Daniel, and great way to see it. For those of you guys that are kind of looking at this, like I said, this is basically no different than what you guys have been doing in the past with the mill turn side of things. Just more, like I said before, more end on the post processor and the channel sync end to be able to do multiple things at once. But no, I definitely think great presentation, Daniel. So,
and I will echo that that comment. I guess what I see here is you've got SolidCAM milling, turning, mill turn, and now this is just kind of the natural progression to give the users that added functionality, being able to go to the next level, being able to do more complicated things easier by using a CAM system, the CAM system you're used to using. There's been a couple questions about pricing and stuff like that. Now that is dictated by the market that that you're in, which country you're in, that type of thing. So work with your local reps and things like that to kind of see what it would take to get to this level of software. Daniel, I want to say thank you. It's a fantastic job of what you showed here today. kind of giving our customers the exposure to the latest stuff that SolidCAM's come up with in development. And this is, really applaud Emil and the rest of the development team in implementing this. This is fantastic functionality. So
pleasure is mine.
Thank you again, Daniel.
And Daniel, we did have one question come up. Do we support impositioning machining or imposition machining?
Okay, yeah, of course. Superimposition. Okay, so there's different terms of superimposition or positioning, super whatever. It's in most of the cases it's superimposition. Yes, we do. Basically, whenever you have part transfer, what I show you over here, when you grab the part with a back spindle, everything is basically in superimposition mode. So it means that you can do turning, milling, everything where you will gonna see the part is being moved along the Z1 axis, where the back spindle follows that position. It's pity that I didn't prepare that one, but definitely yes. The superimposition is just part of the Swiss type module.
Awesome. Can you kind of explain what the imposition machining kind of does? Just, you don't have to show us, just kind of give an explanation. Is that where the main spindle and the sub spindle are synced up together, moving back and forth?
Okay, it depends from kinematic to the kinematic. Okay, there is different situations where you can use superimposition. For instance, on this machine, I'll just jump into the machine itself. It will be much easier for me to explain it, or maybe go to the MCO itself. Yeah, so I'll go to the pig off, and I'll just move this up over here, and going to the machine preview, zoom in a little bit. I like this feature over here, focus target, so it's maybe not bad to show it to you guys. And when I go to the clamp position over here, in these cases there are parts that are pretty long, okay, and in that case to have possibility to machine it correctly and not get vibration. So I'm talking about when the length is more than 5D. In that case, you need to clamp. For example, this part it's pretty long, and if you want to machine something over here, in this case it will be pretty fine. But if you have pretty small diameter, you want to get the support of the back spindle. In that case, what you will expect, the back spindle will come over here, it will clamp the part, and you will take some turning and milling operations. When you do that, and if you are changing the Z1 in this case, so the bar is moving along the guide bush along the Z axis, the back spindle basically holds the part and follows the Z1 axis. In this case, the back spindle itself, as you can see on the bottom over here, is the Z2 axis. So in this case, the superimposition in this case means whatever Z1 axis does, Z2 should follow, okay? And in this case, it only has the purpose to support a part, okay? But there is different examples, and I think I can show you that. Let me just it will maybe take some. Let me just try over here. Maybe like I think it was over here. Why not? I'll just show you guys.
Nothing like putting you right on the spot, right, Daniel?
Yeah, I'll just try it. Swiss tie, maybe channel synchronization. Why not? So just double click over this presentation. I'll just jump to superimposition. I prepared this. So in this case, the superimposition, what we'll do, it's completely different machine. I will not call it. This is a Swiss type. This is not a Swiss type machine either. If it's coming from a Citizen, but this is not a SynCom. This is a Miano. It allows you to, as you can see, also the back spindle. It's kind of following, but not the main spindle in this case. In this case, it follows the turret. It allows you to have two different tools. As you can see in this case, it's a turning tool, which they are completely different X level, and allows you to simultaneously at the same time do two jobs on the main and back spindle on the same station. So superimposition has many, how should I say this? Many purposes. Depends from kinematic to the kinematic, and the mostly depends from kinematic to kinematic, but also what you actually want to do with it. Okay. So in this case, it just allows you to run the two operations together with the one turret. Okay, while the back spindle will follow wherever the tool is located while it's moving also in the main spindle, as you can see on this slide over here.
And this is basically all controlled with the channel synchronization, correct?
This will be automatically detected by the channel synchronization.
Yep.
As you can see on the left side over here, the only thing what you have to do is just to say, okay, please make me the operation of the main spindle. Please do it also on the back spindle. And SolidCAM will automatically detect it's superimposed. As you can see it on the over here, we have the Z1, X1, and they have a small S over here. I'm not sure are you able to see it, but there is a small S. Basically, SolidCAM automatically detects this is a superimposition, so the user don't have to worry about that. The only thing what the user has to do is just to synchronize those two operations, and if there are possibility to make a superimposition in this case, it will be done automatically.
Oh, very cool. Very, very cool. I'm blown away, and I work here.
I'm glad to hear that.
Any other questions, guys, that you would have for Daniel? As long as we have him here. Everybody says great presentation, so looks good. I don't see any more questions coming in. So, and like, if you guys do have questions, definitely feel free. You guys should all have my email address now. Shoot me an email, and we'll be able to answer those questions for you guys as well if you guys want to take it offline. And if you guys would like to kind of see a demonstration of this maybe on your own part, we can definitely get that set up for you guys as well. And this is something that has been in the works for a while. And Dana, do you know how many customers offhand that are using the new Swiss module?
Okay, I'm not pretty sure because it's kind of, I can tell you like in Europe, we do have like between 40 and 50, but there's quite a lot also in Asia. Mm-hmm. We do have also quite a few in Australia. So I'm not 100% sure about the number, but we are pretty fresh in this. This is a pretty new, like a first version of it. So we are kind of spread this news, and so it's going customer by customer, success by success.
Yeah, and I guess what I was getting at is this isn't if you guys are looking at purchasing this module, you're not the first customer at all. So I know it's a new for everybody that's seen it, but you are not the newest customer. So like Daniel's saying, over in Europe, they got 40, 50 people there. And then Asia and all those different countries as well. So you guys will be definitely well taken care of. So. All right. Well, with that being said, we'll kind of wrap things up here. And if we don't have any other questions, I don't see anything else coming in.
Anything else coming in?
Yep.
Kevin, I just want to say thanks for continuing to do the class and getting, organizing this with Daniel to, take a look at the Swiss turning. This is, great presentation again, Daniel and Kevin. Appreciate you doing the class every week.
Yeah, absolutely. And next week, we are going to be doing a sneak peek at what's new in SolidCAM 2019 with Sydney. So we're getting all of our international people in here. So definitely try to make that one next week if possible, or at least watch it on YouTube, because there's going to be a lot of cool stuff on there coming out for 2019 for you guys. But I'll stop rambling here and we'll kind of end it off. And like I said, any questions, concerns come along the way, shoot me an email or give us a call here. And we'll talk to you guys next week. All right. Thanks, guys. Have a great evening. Bye-bye.
Thank you very much. Bye-bye.